There's a profound lie hidden in the very way we perceive the world, a deception so seamless that for most of human history, we never even suspected it existed. When you step outside tonight and look up at the tapestry of the night sky, you intuitively feel that you are witnessing the universe as it is right now. You see a star twinkle, and you assume that the event of that twinkling is happening at the exact moment it registers in your eye. It feels immediate, tangible, and present. But this is an illusion. You are not looking at the universe. You are looking at a graveyard. The light that touches your retina tonight is a ghost, a messenger from a past that no longer exists. Some of those stars have already burned out, collapsed into darkness, or exploded into silence millions of years ago. Yet to your eyes, they are still there, shining with the vitality of the living. We live in a universe where the concept of now is fractured, a place where nothing you see is truly happening in the present tense. To understand why we are trapped in this temporal echo, we must go back to a time when humanity believed light was instantaneous, a divine force that required no time to travel from the heavens to the earth. For centuries, the greatest minds in history believed that light was infinite in speed. Aristotle argued that light was not a movement, but a state of presence, a quality of the medium itself. If you light a candle in a dark room, the walls are illuminated instantly. There is no perceptible delay, no lag between the spark and the sight. To the human sensory experience, light is absolute. It simply is. This belief held firm until the early 17th century, when the inquisitive mind of Galileo Galilei began to question the nature of this immediacy. He suspected that light, like sound, must take some amount of time to travel, even if that time was impossibly short. In 1638, he climbed a hillside outside of Florence, determined to catch light in the act of moving. The experiment was elegant in its simplicity, yet doomed by the limitations of human biology. Galileo stood on one hill, and his assistant stood on another, nearly a mile away. Both men held covered lanterns. The plan was straightforward. Galileo would uncover his lantern, sending a flash of light across the valley. The moment his assistant saw the light, he would uncover his own lantern in response. Galileo would then measure the time it took for the return signal to reach him, hoping to calculate the speed of light by dividing the distance by the delay. But as they stood there in the Tuscan darkness, flashing signals back and forth, Galileo found nothing. The return flash appeared instantly. No matter how far apart they stood, the light seemed to cross the distance in zero time. Galileo eventually concluded that light was either infinite in speed or simply too fast for human reflexes to measure. He was right about the latter. He was trying to catch a photon with a stopwatch made of flesh and bone. He needed a bigger laboratory. He needed a distance so vast that even light would get tired crossing it. The answer would not come from the hills of Italy, but from the cold mathematical silence of the Paris Observatory in the 1670s. A Danish astronomer named Ole Rømer was obsessed with the clockwork precision of the solar system. He was studying Io, the innermost moon of Jupiter. Io is a faithful cosmic timekeeper, orbiting Jupiter rapidly, disappearing behind the giant planet's shadow and reappearing with predictable regularity. Astronomers used these eclipses as a universal clock to coordinate maps and longitude, but Rømer noticed a disturbing glitch in the machinery. The clock was drifting. Over months of meticulous observation, Rømer realized that when the Earth was swinging closer to Jupiter in its orbit, Io's eclipses happened earlier than predicted. When Earth was moving away from Jupiter to the far side of the solar system, the eclipses arrived late. The difference was significant, up to 22 minutes. The scientific community at the time was baffled, wondering if Io's orbit was erratic or if Jupiter's gravity was fluctuating. Rømer looked at the data and saw something deeper. He realized the moon wasn't changing its speed. The news of the eclipse was simply taking longer to reach us. This was a moment of terrifying realization for physics. Rømer deduced that when Earth is on the far side of the Sun, the light from Jupiter has to travel an extra distance equal to the diameter of Earth's orbit. That delay, those missing minutes, was the time it took for light to cross the void. For the first time in history, humanity had proof that light was not magic. It was a traveler, it had a speed limit, it was finite, and if light took time to travel, it meant that the image of Jupiter we see in the telescope is not the Jupiter of the present, but the Jupiter of 20 minutes ago. A Romer had inadvertently discovered that looking out into space is equivalent to looking back into time. This discovery shattered the philosophical comfort of the universal now. If light takes time to travel, then reality is not a unified experience. It is fragmented by distance. Consider the implications for your own life. When you look at the sun, you are seeing it as it was 8 minutes ago. If the sun were to suddenly vanish, you would continue to feel its warmth and see its light for 8 minutes while orbiting a ghost. You would be blissfully unaware that the center of your solar system had ceased to exist. The reality of the sun's death would be racing toward you at 670 million miles per hour, but until it arrived, you would be living in a past that was no longer true. As we look deeper, the lag becomes haunting. The nearest star to us, Proxima Centauri, is 4 light years away. If there were a civilization there watching us with powerful telescopes, they would not see us as we are tonight. They would see us 4 years ago. They would see a world prey, occupied with the events of the past, unaware of the future that has already happened to us. Look further, to the Andromeda Galaxy, a faint smudge of light visible to the naked eye on a clear night. That light left its source 2.5 million years ago, before human civilization existed, before the ice ages, before we had language to describe what we were seeing. When you look at Andromeda, you are catching photons that began their journey when our ancestors were just learning to walk upright. The galaxy itself might have collided with another or changed entirely in the interim. But we are locked in a delay so vast that the truth is effectively inaccessible. This is the cosmic frame rate at its most visceral level. We are not just separated by space, we are separated by time. Every object in the universe is enclosed in a bubble of causality. We can never touch the true present of another star or another galaxy. We are condemned to only ever know their past, and this leads to a thought that is both lonely and deeply peaceful. You are always alone in your own time. Even in your own room, looking at the wall across from you, there is a delay. It is infinitesimal, a fraction of a nanosecond, but it is there. You never see the world exactly as it is. You see it as it was a moment ago. Your brain stitches together a collage of outdated sensory data to create the illusion of a continuous now. But it is just that, a construction, an approximation. The universe does not present itself to you instantly. It streams itself to you, pixel by pixel, photon by photon, across the chasm of space. But why does this delay exist? Why isn't the universe instant? For centuries after Romer, scientists accepted the speed of light simply as a number, a fast but arbitrary velocity that light happened to travel. They did not realize that this speed was not just about light. They didn't understand that they had stumbled upon the structural limit of reality itself. They thought they were measuring the speed of a particle. In truth, they were measuring the refresh rate of existence. The mystery deepened as the centuries turned. If light was a wave, as experiments suggested, it needed a medium. Ocean waves need water. Sound waves need air. It seemed logical, or inevitable even, that light waves needed a substance to ripple through. Scientists named this substance the luminiferous ether. It was a hypothetical, invisible fluid that filled the entire universe, a stagnant ocean of nothingness through which planets drifted and light propagated. It was a comforting idea. It restored a sense of absolute order. If the ether existed, it meant there was a stationary background to the universe, a fixed stage upon which the drama of the cosmos played out. But the ether was a lie, and the uncovering of that lie would require the greatest failed experiment in the history of science and the mind of a patent clerk who dared to ask what would happen if he chased a beam of light until he caught it. We are about to leave the era of intuition and enter the era of the impossible. We are about to discover that the speed of light is not just a number. It is a prison bar, and we are all inside. The late 19th century was the golden twilight of classical physics, a time of supreme intellectual arrogance when humanity felt it had finally mapped the architecture of the cosmos down to its finest gears. We had unlocked the laws of thermodynamics, tamed the forces of electromagnetism, and mathematically described the orbits of the planets with such precision that the universe appeared to be a finished puzzle. Lord Kelvin, one of the giants of the era, famously remarked that there was nothing new to be discovered in physics now. All that remained were more and more precise measurements. The universe was viewed as a grand, silent clockwork mechanism, predictable, sturdy, and absolute. But there was one ghost haunting this machinery, a theoretical necessity that scientists whispered about in the hallowed halls of universities. They called it the luminiferous ether. It was the invisible stage upon which the universe performed its play, a substance so subtle yet so necessary that it had to exist for our understanding of reality to make sense. Logic dictated that if light is a wave, as experiments with prisms and interference patterns had proven, it absolutely must wave through something. This was not a matter of debate, it was a matter of definition. Sound is a vibration of air. Without air, there is no sound. Ocean swells are a vibration of water. Without water, there is no wave. It seemed physically impossible, bordering on the supernatural, to suggest that a vibration could travel through a vacuum. How can a ripple exist without a fluid to ripple within? How can a shudder move through nothingness? So, the physicists of the Victorian era assumed the existence of the ether, a motionless, invisible, weightless fluid filling every cubic inch of space, permeating the gaps between atoms, passing through planets and stars as if they were made of mist. It was the absolute reference frame, the stillness against which all motion could be measured. To believe in the ether was to believe that the universe had a fixed background, a canvas that stood still while we moved across it. Proving the existence of this ether became the final holy grail of 19th century science, the last piece of the puzzle that would complete our mastery of nature. In the year 1887, in a stone basement at Case Western Reserve University in Ohio, two American scientists, Albert Michelson and Edward Morley, prepared to capture this ghost. They did not intend to revolutionize physics, they intended to confirm it. They built a device of exquisite sensitivity called an interferometer, a machine designed to measure the invisible breath of the universe. The logic of their experiment was grounded in the simple reality of planetary motion. As the Earth orbits the Sun, it plows through space at a speed of 67,000 miles per hour. If the ether existed, our planet should be rushing through it, creating a constant ether, wind blowing against us, just as a convertible driving down a highway creates a wind in the faces of its passengers. Michelson and Morley reasoned that a beam of light traveling into this wind should be slowed down, struggling against the current of the cosmos, while a beam of light traveling perpendicular to the wind should cut across it with less resistance. By splitting a single beam of light into two paths at right angles to each other and then recombining them, they could look for interference patterns of light and dark bands that would shift if the two beams arrived at different times. If the ether wind existed, the beams would be out of sync. To achieve this, they mounted their sensitive optical equipment on a massive block of sandstone, a slab of rock weighing nearly a ton. But even the vibrations of footsteps or horse-drawn carriages on the street outside could ruin the delicate measurements. So, in a stroke of engineering genius, they floated this massive stone slab in a circular trough filled with liquid mercury. The mercury provided a nearly frictionless bearing, allowing the heavy stone to float and rotate smoothly, isolated from the noisy, trembling world above. It was a perfect, silent island of measurement. Michelson and Morley spent hours in that basement, slowly rotating the stone, watching the eyepiece for the tail shift of the interference fringes. They expected to see the signature of Earth's motion through the stationary ether. They expected to see the proof of the cosmic background. They held their breath, their eyes adjusting to the darkness, waiting for the universe to reveal its structure. And they found absolutely nothing. The silence of that result was deafening. It was a null result so precise that it screamed at them from the data. No matter which way they turned the device, no matter the time of day, no matter the season of the year, the speed of light remained exactly the same in all directions. There was no wind, there was no drag, there was no ether. The light did not care about the Earth's motion. The light did not care about the direction. It simply traveled unbothered and constant. For 20 years, the community of physics was in a state of quiet panic. This result was not just a failed experiment, it was a catastrophe for the standard model of reality. If there was no medium, what was light waving through? If there was no fixed background to the universe, how could we say we were moving at all? Motion requires a reference point, and the ultimate reference point had just evaporated. The old guard of physics was too terrified to let go of the machine they had built. Leading minds like Hendrik Lorentz and George Francis Fitzgerald invented convoluted, desperate excuses to save the ether theory. They suggested that perhaps the ether physically compressed objects moving through it, squashing the interferometer just enough to hide the effect of the wind. They were trying to patch a sinking ship with mathematical tape, refusing to accept that the ship itself was an illusion. It would take a mind unburdened by the academic dogmas of the time to see the truth that everyone else was ignoring. It would take a patent clerk in Bern, Switzerland, a young man named Albert Einstein, who sat amidst stacks of technical drawings and clock mechanisms, dreaming of the impossible. Einstein did not try to save the ether. He did not try to fix the old equations. He simply asked a question that had haunted him since he was 16 years old. He imagined himself chasing a beam of light. He asked himself, if I could travel at the speed of light, what would I see? Newtonian physics provided a clear answer. If you travel at the same speed as a wave, the wave should appear to stand still relative to you. You should see a frozen electromagnetic field, a static oscillation of energy suspended in space like a painting of a wave. But Einstein knew that Maxwell's equations, the absolute laws governing electricity and magnetism, did not allow for frozen light. Light was self-propagating. It existed only in motion. If it stopped, it ceased to exist. This contradiction was the seed of special relativity. Einstein realized that we were looking at the problem backward. We were trying to force light to obey our intuitive understanding of space and time. But light is the fundamental constant of the universe. And space and time are merely the variables that must adjust to accommodate it. He realized that if the laws of physics were to remain the same for everyone, then the speed of light had to be the same for everyone, regardless of their own speed. It didn't matter if you were standing still on a platform or chasing the beam at 1,000,000 miles an hour. If you measured the speed of that light, it would always, unchangingly, be the same. This sounds simple on the surface, but the implications are horrific for our intuition. It implies that the universe is actively conspiring to present the same speed to every observer. Consider the train paradox that Einstein used to illustrate this breakdown of reality. Imagine you are standing on a train platform and a train speeds past you at half the speed of light. Two bolts of lightning strike the front and back of the train at the exact same moment from your perspective. You see the flashes happen simultaneously. But for a passenger sitting in the middle of that speeding train, the reality is different. Because they are rushing toward the light from the front and away from the light at the back, they will see the front strike happen first. They will insist with absolute truthfulness that the events were not simultaneous. Who is right? In the old physics, one of you had to be wrong, but Einstein showed that you are both right. Simultaneity is not a universal fact, it is a local illusion. Two events that happen now for you might happen at different times for someone else. There is no universal now. The concept of a shared moment across the universe dissolved. The ether was gone, and in its place, Einstein gave us space-time, a dynamic, warping fabric that bends, stretches, and compresses to enforce the tyranny of light speed. To keep the speed of light constant for all observers, the universe must distort the measurements of the observers themselves. If you move fast enough, space physically condenses. The distance between stars shrinks in the direction of your travel, not as an optical illusion, but as a physical reality. And, more terrifyingly, time itself slows down. This was the death of the cosmic clock. There is no master timepiece ticking away the seconds of history. Your time is personal. It belongs only to your reference frame. We had to sacrifice the stability of reality to preserve the speed of causality. But this was only the beginning of the trap. Einstein's equations revealed a barrier, an asymptotic wall that rises up to meet anyone foolish enough to try and break the limit. We are not just slowed down by this limit, we are crushed by it, and the faster we go, the heavier the chains of existence become. To understand the true nature of the cage we live in, we must leave the blackboard behind and strap ourselves into the cockpit of a machine that does not exist. We need to conduct the ultimate thought experiment, one that pushes the laws of physics to their absolute breaking point. Imagine a spacecraft built without the limitations of engineering, a vessel equipped with an engine of infinite thrust and a fuel tank that never runs dry. This is the impossible ship, and its only mission is to break the speed of light. You sit in the pilot's seat, strapped into a crash couch designed to withstand crushing forces, staring at the black void of the cosmos ahead. You ignite the engines. The G-force slams you back, a brutal, steady pressure against your chest. According to Isaac Newton and the classical laws of motion that governed science for centuries, if you keep this thrust constant, your acceleration should be constant. You should gain speed linearly, second after second, hour after hour. In a Newtonian universe, there is no speed limit. If you push something long enough, it will eventually go infinitely fast. You could cross the galaxy in time for dinner. But we do not live in Newton's universe, we live in Einstein's. And as you accelerate, you are about to feel the structure of reality tighten around you like a noose. At first, everything feels deceptively normal. You breeze past 10% of the speed of light, then 20%. The stars outside begin to distort, their light shifting toward the blue end of the spectrum as you rush into their photons, a phenomenon known as blue shift. The radiation hitting the front of your ship becomes more intense, energetic, and dangerous. By the time you reach 50% of the speed of light, you are traveling at nearly 150,000 kilometers per second. You are fast enough to circle the Earth 4 times in a single heartbeat. Yet, inside the cockpit, the physics seem identical to when you were standing still. Your coffee stays in its cup. Your breath comes easily. This is the principle of relativity at work. The laws of physics are the same in all inertial frames, but this comfort is a trap. You're approaching a boundary that is not merely physical, but mathematical. As you push the throttle past 80% of the speed of light, something strange begins to happen. The engine is still roaring with the same ferocity. The fuel is burning at the same massive rate. The force pressing you into the seat has not changed by a single Newton. But the speedometer is barely moving. You are pouring energy into the system, but the returns are diminishing. It feels as though the ship is dragging an invisible anchor, or as if the vacuum of space itself has thickened into invisible molasses. You push the throttle to maximum. You dump the energy equivalent of entire stars into your engines. You inch from 90% to 95%, then to 99%. You are fighting for every fraction of a decimal point. The universe has engaged a mechanism of resistance that feels almost malicious. Where is all that energy going? If it is not making you faster, what is it doing? This is where Einstein's most famous equation, E equals mc squared, reveals its teeth. We are often taught in school that this equation explains nuclear power, that a little bit of mass can be converted into a lot of energy. That is how atomic bombs work. But the equation works both ways. Energy can be converted into mass. As you pump kinetic energy into your ship to make it go faster, that energy has to go somewhere. As you approach the light speed barrier, the universe refuses to let that energy become velocity. Instead, it condenses that energy into inertia. Effectively, your ship is becoming heavier, not physically larger, but more massive in terms of its resistance to motion. Physicists call this the gamma factor or the Lorentz factor. At low speeds, gamma is equal to 1. But as you approach light speed, gamma begins to climb toward infinity. The faster you go, the more energy you add. The more energy you add, the more massive you become. The more massive you become, the harder it is to accelerate. It is a feedback loop of impossibility. By the time you reach 99.9% of the speed of light, your ship effectively weighs 22 times its resting mass. If you push to 99.9999%, your mass increases by a factor of hundreds. To push that last tiny fraction of a percent to reach 100% of light speed would require not just a lot of energy, but infinite energy. You would need to burn the entire universe as fuel every star, every galaxy, every atom just to reach the limit, and even then, you would only touch the asymptote. You would never cross it. The barrier is not a technological hurdle, it is a mathematical wall of infinity. This is not just theoretical. We see this happen every day in our particle accelerators. At the Large Hadron Collider in Switzerland, we accelerate protons to 99.9999999% of the speed of light. At that speed, a single microscopic proton carries the kinetic energy of a flying mosquito. That sounds small, but for a subatomic particle, it is monstrous. To make that proton go just a tiny bit faster, to close that last gap of 0.000000001%, we have to pump in exponentially more energy. The accelerator magnets have to scream with power just to keep the particle on track because the proton has become so heavy with relativistic mass. We bump against the wall of light speed every time we run an experiment, and the wall never budges. But the punishment for speed is not just physical heaviness, it is temporal theft. As you fight against the light speed barrier, you are engaged in a cosmic currency exchange. We exist in a four-dimensional structure called space-time. You are always moving through this structure. Even when you are sitting still in your chair, you are hurtling through time at the speed of light. That is your default state. Maximum speed through time, zero speed through space. But when you start to move through space, you have to divert some of that velocity. You have to borrow from your speed through time to pay for your speed through space. This is the cruel geometry of our existence. The faster you move through space, the slower you must move through time. On your impossible ship, as you scrape against the light, speed barrier, time outside your window begins to accelerate wildly. You look at the universe, and you see galaxies spinning like tops, stars being born and dying in seconds. Entire civilizations rise and fall in the blink of an eye. Inside the cockpit, your watch ticks normally. Your heart beats at its usual rhythm, but you have become decoupled from the rest of existence. This is called time dilation. If you were to return to Earth after what felt like a one-year journey at 99.9% of light speed, you would find that decades or even centuries had passed for everyone you ever loved. You would be a ghost from the past, stepping into a future that does not know you. You have traveled forward in time, but the price was your connection to the present. And there is another distortion, perhaps even more terrifying: length contraction. As you accelerate, space itself begins to crush in the direction of your motion. The universe literally shrinks. If you could travel at 99.5% of the speed of light toward a star that is 10 light years away, the distance to that star would physically contract to just one light year from your perspective. If you hit 99.999%, the entire galaxy would flatten into a thin disk. Space is not a fixed stage. It is an accordion that folds up as you gain speed. For a photon traveling at exactly the speed of light, the entire universe contracts to zero. The distance from the beginning of time to the end of time is zero. This is why photons, the particles of light, can travel at light speed. They have no mass. They pay no tax to the Higgs field. They carry no baggage. Because they are massless, they must travel at the speed of light. They have no choice. Imagine the life of a photon emitted by a star in the Andromeda galaxy, traveling for 2 million years to reach your eye. To us, that journey takes eons. Humans evolve, build pyramids, invent telescopes, and look up. But to the photon, it is instantaneous. The moment of its birth in the star and the moment of its death on your retina are the same moment. For light, there is no distance. For light, there is no time. The universe is collapsed into a single point of here and now. We, however, are creatures of mass. We are made of atoms, of protons and electrons that carry the heavy burden of existence. We are forbidden from that timeless realm. We are anchored to the slow lane, forced to experience the passage of time, forced to age, forced to wait. The speed of light is the wall that separates the timeless from the temporal. It is the dividing line between the eternal now of the photon and the linear narrative of human life. Einstein showed us this wall, and he showed us that it is impenetrable. No amount of force, no engine, no God, like technology, can push a massive object to the speed of light. To do so would break the mathematics of the universe. It would require infinite energy and would result in the division by zero of reality itself. The human mind does not accept limits easily. We are a species defined by our refusal to stay within the lines. We crossed oceans without maps. We learned to fly despite gravity, and we split the atom despite the risks. When physicists declared the speed of light to be unbreakable, the collective imagination of humanity took it not as a law, but as a challenge. Science fiction writers and theoretical physicists alike began to dream of ways to circumvent the cosmic speed limit. If we cannot go through the wall, surely we can go around it, or under it, or perhaps dissolve the wall entirely. This desire gave birth to the era of exotic physics, a realm of strange equations and hypothetical monsters where mathematics allows for things that reality seems to forbid. We began to look for the escape hatch of the universe, but as we explore these theoretical loopholes, we will find that the universe has a terrifying way of protecting its secrets. One of the most seductive of these theoretical monsters is the tachyon. In the mid-20th century, physicists looked at the equations of special relativity and noticed a mathematical curiosity. The equations forbid ordinary matter from accelerating up to the speed of light because it requires infinite energy. But the equations do not strictly forbid particles that are already moving faster than light. These hypothetical particles were named tachyons, from the Greek word tachys, meaning swift. These tachyons would be the mirror image of ordinary matter. While we require infinite energy to speed up to light speed, a tachyon would require infinite energy to slow down to light speed. They would live their entire existence on the other side of the barrier, forever traveling faster than the cosmic limit. To a tachyon, the speed of light is a floor, not a ceiling. It sounds like a perfect solution, a shadow ecosystem of particles that we could potentially harness for interstellar communication. Imagine sending a message to a star system 10 light years away and having it arrive instantly. But there is a catch so profound it threatens the stability of existence itself. In a relativistic universe, traveling faster than light is geometrically equivalent to traveling backward in time. If you could send a signal using tachyons, you could create what physicists call an anti-telephone. You could send a message to your past self. You could warn yourself of a mistake you have not made yet. You could prevent your own birth. This creates a causal loop, a paradox that destroys the logical consistency of reality. If you prevent the accident that caused you to send the warning, then you never send the warning, so the accident happens, so you send the warning. The universe cannot resolve this. It is a fatal error in the operating system of existence. Because of this violations of causality, most physicists believe that tachyons do not exist. They are mathematical ghosts, allowed by the equations but forbidden by the logic of reality. The speed of light is not just a speed limit for motion, it is a speed limit for causality. For it exists to protect the timeline from destroying itself. If we cannot break the speed limit with particles, perhaps we can cheat with quantum mechanics. We know that subatomic particles can do things that are impossible for solid objects. They can tunnel through barriers. This is called quantum tunneling. An electron can disappear on one side of an impenetrable electric field and reappear on the other without ever passing through the space in between. It is as if a ghost walked through a wall. Could we use this to tunnel past the light speed barrier? In the 1990s, experiments were conducted where photons seemed to tunnel across a gap faster than light could travel. For a brief, intoxicating moment, headlines proclaimed that the limit had been broken. It seemed that Mozart's music could arrive before the conductor raised his baton. But closer inspection revealed a subtle, heartbreaking trick. A pulse of light is not a single point. It is a wave packet shaped like a bell curve. When it tunnels, the front edge of the packet is suppressed and the peak of the wave appears to shift forward. It looks like the pulse arrived early. But the actual information, the signal that carries meaning, the news of the pulse, never exceeds the speed limit. It is like sending a letter that arrives before the envelope, but the letter is blank until the speed of light catches up. Nature allows the shadow of speed, but not the substance. Quantum mechanics is weird, but it is not lawless. It respects the barrier just as strictly as classical physics. Then came the dream of the warp drive. In 1990, a Mexican physicist named Miguel Alcubierre proposed a solution that seemed to obey Einstein's laws while still allowing for faster than light travel. He suggested that instead of moving the ship through space, we could move the space itself. Imagine the universe as a tablecloth and the starship as a dinner plate. You cannot slide the plate faster than the friction allows, but you can pull the tablecloth, bringing the destination to you. The Alcubierre drive would contract the space in front of the ship and expand the space behind it, creating a wave of space-time. The ship would ride inside this bubble, technically stationary, while the bubble itself surfed across the cosmos faster than light. Inside the bubble, time would flow normally. There would be no g forces, no time dilation. The crew could fly to Alpha Centauri for lunch and be back for dinner, having aged only a few hours. It seemed perfect. It was the Star Trek dream made mathematical. But the universe charges a price for this magic, and the price is something called negative energy. To warp space in this way, you need a form of matter that has negative mass, something that weighs less than nothing. Gravity usually attracts. Negative energy would have to repel. We have never seen such a substance in the macroscopic universe. Even if we could create it, the amount required to transport a small ship was initially calculated to exceed the total energy of the visible universe. Later calculations brought this down to the mass of Jupiter, which is still an insurmountable engineering challenge. But the problems with warp drives go deeper than fuel. And there is the horizon problem. If you are moving faster than light, you cannot send a signal to the front of your own warp bubble to tell it to stop or turn. You would be trapped inside a runaway bubble, unable to steer, hurtling across the universe until you ran out of energy. And worse, as you travel, your warp bubble would sweep up high, energy particles from the vacuum of space, accumulating them on the front wall of the bubble like bugs on a windshield. When you finally arrived at your destination and turned off the drive, that accumulated radiation would be released in a focused blast, potentially sterilizing the very planet you came to explore. The drive effectively becomes a doomsday weapon. Finally, we look to wormholes, the Einstein, Rosen bridges. These are shortcuts through the fabric of spacetime, on tunnels that connect two distant points. In theory, you could step into a wormhole near Earth and step out near the Andromeda Galaxy without crossing the space in between. You wouldn't be traveling faster than light locally, you would just be taking a shorter path. But wormholes are inherently unstable. The moment a single photon enters the tunnel, the gravity of that energy causes the throat of the wormhole to collapse, snapping shut faster than light. To keep it open, you again need negative energy to prop the walls apart. And even if you could build one, a wormhole is also a time machine. If you move one end of the wormhole at high speed and bring it back, you connect two different points in time. You could step through and emerge in your own past. This brings us back to the ultimate enforcer causality. Every single method of faster, than light travel, whether it is tachyons, warp drives, or wormholes, eventually leads to the same paradox. They all allow you to kill your own grandfather. They all allow effect to precede cause. The universe seems to possess a chronology protection mechanism, a hidden law that prevents closed time-like curves from forming. Stephen Hawking famously conjectured that the laws of physics conspire to prevent time travel on a macroscopic scale to keep the universe safe for historians. Every time we find a loophole, nature closes it. We try to push mass to light speed, and nature gives us infinite inertia. We try to warp space, and nature demands impossible energy. We try to build tunnels, and nature collapses them with instability. This leads us to a chilling conclusion. The speed of light is not a challenge to be overcome. It is not a puzzle to be solved. It is a fundamental resolution of the universe. It is the pixel size of reality. We are not meant to leave our local bubble of causality. We are trapped in the present, separated from the past and the future by an unyielding wall. But why? Why is the universe so terrified of us moving fast? Why is causality so fragile? To answer that, we must stop looking at rockets and black holes and start looking at the smallest scales of existence. We must turn to the man who saw reality not as a single line, but as a dance of infinite possibilities. We must turn to Richard Feynman and the day he realized that the reason we cannot break the speed of light is because, in a strange quantum sense, we are already everywhere at once. We have looked at the wall from the perspective of the prisoner, feeling the cold, hard limits of mass and energy. We have looked at it from the perspective of the escape artist, trying to tunnel through with wormholes and warp drives, only to find the exits barred by paradoxes. Now, we must look at the wall from the perspective of the architect. To understand why the speed of light is the absolute limit, we must dive beneath the smooth geometric fabric of Einstein's spacetime and enter the chaotic, buzzing basement of reality quantum mechanics. And our guide into this madness is Richard Feynman. Feynman was not your typical physicist. He was a safe-cracking bongo-playing iconoclast who refused to accept that nature was as stiff and formal as the textbooks claimed. In the 1940s, he looked at the behavior of particles like electrons and photons, and he grew dissatisfied with the standard explanations. Classical physics, the physics of Newton and even Einstein, assumes that a particle travels from point A to point B along a single, definite path. If you throw a baseball, it follows one specific arc determined by gravity and momentum. It does not fly to the moon, circle Mars, and then come back to the catcher's mitt. It takes the most efficient route. This is the principle of least action. But Feynman asked a question that would rewrite the laws of reality. What if the particle does not choose? He developed a framework called the path integral formulation, also known as the sum over histories. Feynman suggested that when a quantum particle moves from one place to another, it does not calculate the best path. It takes every possible path simultaneously. This is not a metaphor. It is not a poetic exaggeration. The mathematics of quantum electrodynamics, the most precise theory in the history of science, dictates that to calculate the probability of a particle arriving at a destination, you must add up the contributions of every conceivable trajectory it could have taken. Imagine an electron moving from a lamp to your eye. In Feynman's view, that electron takes the straight path. But it also takes a path that curves slightly to the left. It takes a path that loops around the ceiling. It takes a path that travels to the edge of the galaxy, dances around a black hole, and returns to your eye. And, crucially for our story, the mathematics includes paths where the particle travels faster than the speed of light. It includes paths where the particle travels backward in time. The electron sniffs out every corner of the universe, it exploring every possibility, no matter how absurd, before settling into the reality we observe. So, here is the terrifying question. If the math includes paths that go faster than light, why don't we see particles breaking the speed limit? Why is the universe orderly? This is where the magic happens. This is the quantum censorship. To understand this, we must visualize the internal clock of a particle. In quantum mechanics, every path contributes something called a probability amplitude. This amplitude has a magnitude and a direction, like a clock hand. Physicists call this the phase. As a particle travels along a path, this little clock hand rotates. The speed at which the clock hand rotates depends on the energy and the time of the journey, a quantity known in physics as the action. For the wild paths, the paths that zig, zag violently, the paths that loop around stars, and the paths that attempt to break the speed of light, the action is enormous and highly sensitive. On these extreme trajectories, the internal clock spins wildly. A tiny change in the path causes the clock hand to point in a completely different direction. One path's clock points up. A neighboring path, just a fraction of a millimeter different, has a clock that points down. Another points left. Another points right. When you try to add up all these billions of crazy paths, their conflicting clock hands cancel each other out. Up cancels down, left cancels right. This is called destructive interference. The illegal paths, the superluminal paths, the paths that violate common sense, are all mathematically there in the beginning, but they annihilate each other in the final sum. They destroy themselves before they can become reality. However, there is one specific set of paths where the cancellation does not happen. These are the paths very close to the classical trajectory, the straight line. For these paths, the action is minimized. The internal clock rotates slowly and steadily. If you shift the path slightly, the clock hand barely moves. It still points in roughly the same direction. Because these arrows are all pointing the same way, when you add them up, they do not cancel. They reinforce each other. This is constructive interference. So the reason a beam of light travels in a straight line at exactly 299,792,458 meters per second is not because the other paths are strictly forbidden. It is because the other paths are self-defeating. The universe is a democracy of infinite possibilities, and the speed of light is the only candidate that survives the vote. The speed of light is simply the path of stationary phase. It is the ridge of stability in an ocean of chaos. The universe does not need a traffic cop to stop you from speeding. It simply arranges the mathematics so that any attempt to speed results in your probability dissolving into zero. This completely reframes our understanding of the limit. The speed of light is not a wall imposed from the outside. It is an emergent property from the inside. The universe allows particles to try to go faster, but those attempts wash out in the quantum foam. Reality, the solid, predictable world we see around us, is just the constructive interference of the most likely histories. We are living in the sum. Feynman's insight goes even deeper, touching the very nature of time itself. In his famous diagrams, those squiggles representing particle interactions that every physics student learns to draw, he showed that there is a profound symmetry between matter and time. If you look at the equations, a particle traveling forward in time is mathematically indistinguishable from an antiparticle traveling backward in time. An electron moving forward is the same as a positron moving backward. This suggests that the speed of causality is the pivot point upon which time balances. We have journeyed through the microscopic world of quantum mechanics, where the speed of light acts as a sensor for chaotic probabilities. We have strapped ourselves into impossible rockets to feel the crushing weight of infinite inertia. But now, we must leave the realm of particles and ships behind to confront the speed of light in its most terrifying arena. We are entering the domain of gravity, where the curvature of space-time becomes so extreme that it breaks the very concepts of yesterday, today, and tomorrow. We are approaching the edge of the known map, where the cosmic frame rate drops to absolute zero, and the universe simply stops updating. This is the story of the event horizon, the black hole, and the accelerating silence of the dying cosmos. To understand the relationship between the speed of light and gravity, we must first unlearn the definition of gravity that Isaac Newton gave us 3 centuries ago. Newton described gravity as a force, an invisible tether that connects the earth to the sun, pulling them together like magnets. It was a clean, simple, mechanical explanation. But it was wrong. Albert Einstein showed us that gravity is not a force at all. It is geometry. Imagine the universe not as an empty box containing objects, but as a fabric, a 4-dimensional sheet of space-time. Mass tells this fabric how to curve, and this curved fabric tells mass how to move. When you drop a cup, It is not being pulled down by a force, it is simply following the straightest possible line through a spacetime that has been curved by the mass of the Earth. Usually, this curvature is gentle. The divot made by the Earth is shallow. The depression made by the Sun is deeper, but still navigable. Light, which always travels in a straight line, bends slightly as it passes these objects, like a race car banking around a curve. But what happens if you compress a massive amount of matter into a volume so small that the fabric of space doesn't just curve? What happens if it rips? What happens if the slope becomes vertical? This brings us to the concept of the black hole, the ultimate enforcer of the light speed limit. To visualize this, forget the popular image of a cosmic vacuum cleaner sucking up dust. Instead, think of space itself as a river that flows toward a waterfall. As you get closer to the edge of the falls, the current moves faster and faster. Imagine you are a fish swimming in this river. As long as you can swim faster than the current, you can escape. You can fight your way upstream. But the closer you get to the drop off, the faster the water flows. At a certain precise distance from the edge, the speed of the water equals your maximum swimming speed. If you pass this point, even if you swim with all your might against the current, you will remain stationary relative to the bank, suspended in a frantic frozen struggle. If you drift even a millimeter closer, the water flows faster than you can swim, and you are dragged backward inevitably over the edge. In a black hole, the water is space-time itself. Space is literally flowing inward, dragging everything with it toward the center, and the swimming speed of the fish is the speed of light. Since nothing in the universe can swim faster than light, 9,792,458 meters per second. There exists a boundary where the inflow of space reaches exactly that speed. This boundary is called the event horizon. It is the point of no return. It is a mathematical line in the sand drawn by the laws of relativity. At the event horizon, space is falling into the singularity at exactly the speed of light. Inside the horizon, space is falling faster than light. This creates a geometric prison that is absolute. If you were to cross the horizon and shine a flashlight outward toward freedom, the photons would launch from your flashlight at the speed of light. They would try to fly away. But the space they are traveling through is being dragged backward faster than they are moving forward. It is like a runner sprinting on a treadmill that is set to a speed higher than their legs can carry them. The photons are moving outward locally, but globally, they are being swept inward to the darkness. But they never reach the eyes of the outside world. The speed limit has effectively severed a piece of the universe, creating a region of spacetime that is causally disconnected from the rest of reality. But the most haunting aspect of the event horizon is not the physics of the fall, but the perception of the observer. This brings us back to the core theme of our journey, the cosmic frame rate. As we learned from Einstein, time is not absolute. It is relative to gravity. The stronger the gravity, the slower time flows. This is time dilation taken to its extreme limit. If you were to stay safely on a spaceship far away and watch a brave volunteer astronaut fall toward a black hole, you would witness something deeply disturbing, something that defies all intuition. As the astronaut falls, they gain speed, accelerating under the crushing grip of gravity. You might expect to see them zip across the boundary and vanish in a blink, but that is not what happens. As they get closer to the horizon, the light coming from their body has to climb out of a gravity well that is getting deeper by the second. Losing energy as it climbs, the light shifts its color, stretching out into longer and longer wavelengths. This is gravitational redshift. The astronaut's white spacesuit turns yellow, then deep orange, then a dull blood red. Simultaneously, the information regarding their movements begins to arrive with greater and greater delays. You are watching the universe's update rate for that astronaut grind to a halt. You would see their movements decelerate. A wave of the hand would take an hour, a blink of an eye would take a week. As they approach the millimeter mark above the event horizon, time dilation becomes nearly infinite. To your eyes, the astronaut would never cross the line. They would simply freeze. They would become a static, reddened image, a ghost plastered against the fabric of the night. Over the course of millions of years, that image would fade, shifting from visible red light to infrared, then to radio waves, becoming dimmer and dimmer until it is indistinguishable from the background noise of the cosmos. But the image never technically disappears. The universe, unable to update the frame because the light cannot escape fast enough, simply leaves their last known configuration stuck on the screen forever. This creates a profound paradox known as the frozen star. To the outside universe, a black hole is a place where history has piled up in layers on the surface, a museum of everyone and everything that has ever fallen in, trapped in the amber of gravitational time dilation. But what about the astronaut? What is their reality? For the person falling in, the experience is radically different. They do not feel time slowing down. Their watch ticks normally. Their heart beats at 60 beats per minute. They do not freeze. They cross the event horizon in a fraction of a second, completely unaware that they have passed a point of no return. The horizon is not a solid wall, it is just empty space, but the moment they cross it, the geometry of the universe flips. This is one of the most bizarre and terrifying predictions of general relativity. Inside a black hole, the role of space and time are swapped. In our normal world, we have freedom of movement in space. You can walk left, right, forward, backward, but you have no freedom of movement in time. You must go forward. You cannot stop tomorrow from coming. Inside the event horizon, the radial direction, the path toward the center, becomes your time. The singularity, the infinitely dense point at the center, is no longer a place in front of you. It is an event in your future. Trying to avoid hitting the singularity is as impossible as trying to avoid next Tuesday. No matter which way you turn, no matter how hard you fire your rockets, you are moving toward the center, because the center is no longer a location. It is a moment. The speed of light ensures that all paths, all timelines, all futures terminate at the singularity. The astronaut looks back and sees the universe outside speeding up, potentially witnessing the entire future history of the galaxy flash by in a few chaotic seconds before the tidal forces of the black hole rip their atoms apart in a process physicists call spaghettification. So the speed of light creates two distinct contradictory realities that can never be reconciled. One reality where the astronaut is frozen on the surface forever, and another reality where they are already dead at the center. The event horizon is a wall of silence that causality cannot penetrate. It is a partition in the hard drive of the universe, separating data that is accessible from data that has been deleted. But black holes, for all their power, are only local prisons. They trap matter and light in specific pockets of the galaxy. The speed of light imposes a much grander, more melancholy isolation on us, one that affects the fate of the entire cosmos. We must turn our eyes from the dark hearts of stars to the vast, expanding emptiness between them. We must talk about the cosmic horizon. For most of human history, we believed the universe was static and eternal. But in the 1920s, Edwin Hubble discovered that the galaxies are rushing away from us. The universe is expanding. The fabric of space itself is stretching, carrying the galaxies along with it like raisins in a rising loaf of bread. For decades, we assumed that this expansion was slowing down, that the gravity of all the matter in the universe was acting as a brake, pulling everything back together. We thought the universe would eventually stop growing and perhaps collapse back into a big crunch. But in the late 1990s, known astronomers studying distant supernovas made a discovery that shook the foundations of cosmology. The expansion is not slowing down, it is accelerating. A mysterious force, which we've named dark energy, is pushing the universe apart, overcoming gravity. The more space there is, the more dark energy there is, and the faster the universe expands. This runaway expansion leads to a chilling consequence involving the speed of light. Velocity is distance divided by time. As space expands, the distance between us and a far-off galaxy increases. The more space there is between us, the more new space is being generated every second. This means that distant galaxies appear to be moving away from us at speeds proportional to their distance. This is Hubble's law. If you look far enough away, you reach a distance where the cumulative expansion of space causes the recession speed of galaxies to exceed the speed of light. Wait, does this violate Einstein's rule? Number. Einstein said nothing can move through space faster than light, but space itself is not a thing, it is the stage. The stage can expand as fast as it wants. The galaxies are not moving through space faster than light, they are riding a wave of expanding space that is separating us from them at superluminal speeds. This creates a cosmic event horizon, a bubble around us roughly 46 billion light years in radius. Beyond this bubble, galaxies are receding from us faster than light. This means that the light they emit now, at this very moment, will never reach us. That light is trying to swim toward Earth at 300,000 kilometers per second, but the river of space is flowing away from Earth at 301,000 kilometers per second. The photon is running a race it can never win. It is trapped in a section of space that will never overlap with ours. We are living in a universe that is disappearing. Every second, as the expansion accelerates, the cosmic horizon shrinks in relative terms. Galaxies that are currently on the edge are crossing over. They are emitting their last reachable photon. They are saying their final goodbyes. We can still see their ancient light, the ghosts of their past emitted billions of years ago when they were closer. But we will never see their today. We will never see their tomorrow. They are disconnected from our causality forever. If there are civilizations in those galaxies looking back at us, they are seeing our Milky Way fade into the red, shifting slowly into darkness until we vanish from their sky just as they vanish from ours. This isolation is absolute. We are being slowly quarantined in a void that gets darker and emptier with every passing eon. Project this forward into the deep future. In roughly 100 billion years, the expansion will be so rapid that every galaxy outside of our own local group, the cluster containing the Milky Way and Andromeda, will have been swept away beyond the horizon. The light from the Big Bang, the cosmic microwave background, will be stretched until it is undetectable. Imagine a civilization born in that distant era. They will arise on a planet orbiting a star in the merged remnant of our galaxy. They will build telescopes and look up. And what will they see? They will see nothing but their own galaxy surrounded by an infinite, static, empty void. They will have no evidence of the Big Bang. They will have no evidence of the expansion. They will see no other galaxies to measure. They will conclude, using the best science available to them, that they are the only island of matter in a stagnant, eternal universe. The speed of light, combined with the expansion, will have erased the history of the cosmos. It will have deleted the evidence of our origins. We are privileged. We live in a brief golden window of time where the universe is transparent enough to reveal its history, but not yet expanded enough to hide its neighbors. We can see the truth of our origins. We can measure the recession of the galaxies. We can deduce the Big Bang. But this window is closing. The speed of light is the shutter that is slowly coming down. The speed of light dictates what is knowable and what is lost. It turns the universe into a series of disconnected islands, separated by oceans of causality that can never be crossed. We are drifting alone in the dark, and the lights on the shore are going out one by one. But this isolation serves a necessary purpose. It preserves the sanctity of the here and now. Consider the alternative. If the speed of light were infinite, gravity would be instantaneous. Every atom in the universe would feel the gravitational pull of every other atom instantly. The universe would likely collapse into a singularity the moment it was born. If light were infinite, the night sky would not be dark. It would be ablaze with the light of infinite stars, blinding us instantly. This is Olber's paradox. The darkness of the night sky is direct evidence that the universe has a speed limit and an age. The darkness is a gift. The isolation is a shield. The speed limit protects us from the infinite. It grants us the peace of a quiet, local existence. It allows pockets of order to form, shielded from the chaos of the rest of the cosmos. We exist because we are disconnected. We survive because we are slow. And this brings us to the final, most uncomfortable question. If the speed of light is the resolution of reality, the update rate of the cosmos, and if it acts as a limiter that prevents the system from crashing, then what are we to make of the system itself? Why is the frame rate set to this specific number? Is it a fundamental constant arbitrarily chosen by nature? Or is it a sign? A sign that our reality is, in some deep sense, computed. A sign that we are running on hardware that has a maximum clock speed? As we prepare for the final chapter of our journey, we must confront the possibility that the speed of light is not just a physical law. It might be a design constraint. We have reached the end of our journey through the architecture of the cosmos. We started on a hilltop in Italy, watching Galileo try to catch a beam of light with a lantern. We traveled through the ether that never was, witnessed the bending of time in Einstein's trains, felt the crushing weight of infinite inertia in our impossible ships, and watched the universe dissolve into probability at the quantum scale. We stood at the edge of the black hole, where time stops, and watched the distant galaxies fade into the eternal silence of the accelerating expansion. We have stripped away every illusion, every comforting lie about the nature of space and motion, until we are left with only one naked truth. The speed of light is not about light. It never was. Light is simply the cosmic messenger, the most visible traveler on the road of reality. But the road itself has a speed limit, and this limit, 299,790,2,458 meters per second, is the fundamental clock speed of existence. It is the tick rate of the universe. When computer scientists build a virtual world, a video game, or a simulation, they have to set a refresh rate. This is the number of times per second the computer calculates the position of every object, the trajectory of every bullet, and the collision of every polygon. If the computer tries to calculate everything instantly, infinite calculations would be required and the processor would crash. So, there is a limit. There is a lag. Information travels from one part of the memory to another at a finite speed. To a character living inside the simulation, this finite speed would look exactly like a law of nature. They would measure the speed of a signal moving through their world and find that it has a maximum velocity. They might call it the speed of light, never realizing it is actually the speed of the processor. This is the simulation hypothesis in its most compelling form. It suggests that the reason we cannot break the speed of light is that the universe is a computational engine and it has a maximum bandwidth. It can only process a certain amount of change per second. Space-time is not a continuous fluid. It is a grid, a lattice of information. When an electron moves from point A to point B, the universe has to delete it from one coordinate and rewrite it at the next. That operation takes time. It takes a finite, non-zero amount of processing power. The speed of light is simply the speed of causality, the delay between the input of a cause and the output of an effect. Consider the alternative. Imagine a universe where the processor speed was infinite, a universe where the speed of light was infinity. In such a world, if a star exploded in the Andromeda galaxy, the light, the gravity, and the radiation would reach Earth instantly. There would be no delay. But it goes deeper. Every force would be instant. Every interaction would be immediate. Causality would collapse. The past, present, and future would all exist in a single simultaneous overlap. There would be no history, because history requires a sequence. There would be no narrative, because narrative requires a pause between the beginning and the end. An infinite speed universe would be a static universe, a singularity of information where everything happens at once. The delay is what gives us time. The lag is what gives us life. The speed of light creates the arrow of time. It ensures that there is a sequence to events. You strike the match before the fire burns. You shout before the echo returns. You live before you die. This chronological protection is only possible because information cannot travel backward and it cannot travel instantly. The speed limit separates the before from the after with an impenetrable wall of duration. It forces the universe to unfold, frame by frame, moment by moment, like a film passing through a projector. We are trapped in the movie, yes, but without the speed limit, there would be no movie at all, just a single, blindingly bright still image. But why this specific speed? Why is the frame rate set to roughly 300,000 kilometers per second? Why not 1 meter per second? Why not a trillion? This leads us to one of the deepest mysteries in all of physics, a number that haunted Richard Feynman to his dying day. It is called the fine structure constant, often denoted by the Greek letter alpha. It is a pure number, approximately equal to 1 over 137. This number combines the speed of light, the charge of the electron, and Planck's constant into a single value that dictates the strength of the electromagnetic interaction. It is the DNA of reality. If the speed of light were significantly faster, the fine structure constant would change. The electromagnetic force would be different. Atoms might not hold together. The electrons would spin out of orbit or spiral into the nucleus. Chemistry, the complex bonding of elements that allows for water, for carbon, for biology, would be impossible. Stars might burn out in seconds or never ignite at all. If the speed of light were significantly slower, the universe might be too sluggish for complex structures to form. Signals would take too long to cross a molecule. Thoughts would take too long to cross a brain. The universe would be a cold, disconnected sludge of matter unable to communicate with itself. We exist in a Goldilocks zone of causality. The speed of light is fast enough to allow stars to shine and minds to think, but slow enough to prevent the universe from crashing into chaos. It is tuned with a precision that defies explanation. Physicists call this the anthropic principle, the idea that we see these specific constants because if they were any different, we wouldn't be here to see them. We are the survivors of the lottery of constants. We are the ones living in the universe that works. This realization transforms the speed of light from a prison into a sanctuary. Throughout this journey, we have described the limit as a wall, a cage, a barrier. We have felt the frustration of being stuck in our local bubble, unable to reach the stars, unable to talk to distant galaxies. We have mourned the silence of the event horizon and the loneliness of the expanding void. But tonight, as you lay in the dark, I want you to feel the comfort of that limit. The speed of light is the shield that protects you from the infinite. Imagine if you could feel everything. Imagine if every event in the universe, every supernova, every collision, every scream of energy reached you instantly. You would be overwhelmed. You would be destroyed. The speed limit acts as a cosmic filter, ensuring that you only have to deal with your local reality. It keeps the rest of the universe at a safe distance. It puts the stars just far enough away to be beautiful, but not close enough to burn. It grants you the privacy of your own now. Remember, because of the delay, no one can see you as you are right this second. To the moon, you are a second ago. To the sun, you are 8 minutes ago. To the stars, you are decades or centuries in the past. In the exact mathematical present, you are completely unobserved. You are hidden in the lag, while you are safe in the gap between the frame and the observer. The universe is a massive dark room, and the speed of light is the size of the candle you hold. It limits how much you can see, yes. It prevents you from seeing the walls of the room or the monsters in the corners. But it also defines your circle of warmth. It defines the space that belongs to you. Within your light cone, you have influence, you have causality, you have agency. Outside of it, you have nothing and nothing has you. So the next time you look up at the night sky and see the ghosts of dead stars, do not feel sad for the delay. Do not feel trapped by the distance. Feel the rhythm of it. Feel the steady, unyielding pulse of the cosmic frame rate. The universe is updating itself, pixel by pixel, atom by atom, with a reliability that has lasted for 13.8 billion years. It has never skipped a frame. It has never crashed. It is rendering your reality with absolute precision. Richard Feynman once said that nature uses only the longest threads to weave her patterns, so that each small piece of her fabric reveals the organization of the entire tapestry. The speed of light is that thread. It connects the tiny dance of the quantum electron to the massive rotation of the galaxy. It connects the ticking of your wristwatch to the expansion of the Big Bang. It is the rule that makes the game possible. As you drift off to sleep tonight, let go of the need to be everywhere. Let go of the need to know everything. You are here, in this frame, in this moment. The universe will handle the rendering of the next one. It will calculate the position of every atom in your body, every beat of your heart, and every dream in your mind exactly on time. You don't have to rush. You literally cannot rush. You are moving at exactly the speed you are meant to move. You are traveling through time at the speed of light, headed toward tomorrow at the maximum velocity allowed by the laws of physics. The barrier is not there to stop you. It is there to hold you together. It is the container of existence. Sleep well, traveler. The simulation is running smoothly.